Let me ask you something. Are you real? And I mean really real. Are your memories actually yours? Now that might sound like just a late-night philosophical question, right? But what if I told you that physics itself, our best understanding of the universe, hints that you, me, and everything we've ever known might just be an incredible cosmic accident? Yeah, stick with me because we are about to dive into one of the most mind-bending and honestly unsettling ideas in all of science.
Okay, so let's just jump right in. We're going to unpack a thought experiment that is so out there it really forces you to question what it means to exist. And it all starts with a very simple but kind of creepy idea: a single conscious brain just floating in the empty, silent void of space. Now here's the thing. This brain thinks it's you. It has all of your memories, your childhood, that embarrassing thing you did in middle school, what you ate for breakfast this morning, all of it. But every single one of those memories is a complete fabrication, an illusion created in the exact same instant that the brain itself just randomly, poof, popped into existence. And this is where it gets truly bizarre. Because according to the fundamental laws of thermodynamics, when you play the tape of the universe forward over unimaginable stretches of time, you get a shocking result. That second option, the single spontaneous brain with all your fake memories, isn't just a possibility, it is statistically far more likely to happen than the entire vast, complex 13.8 billion year history of our universe.
And let's be really clear here, this isn't just some sci-fi plot. This is a genuine paradox that arises directly from our best, most tested theories in physics. So to really understand how we could possibly end up with this conclusion, we need to start with the universe's most inescapable rule. We need to talk about disorder.
You see, pretty much everything in our reality, from your coffee cooling down to the stars burning out, is governed by this one single overarching principle. It's a one-way street that really defines the flow of time itself.
It's called the second law of thermodynamics, and it basically just says that over time, things get messy. Orderly, neat things naturally break down and become more random and chaotic. This universal tendency towards messiness is called entropy, and the rule is simple. It always goes up. This is a perfect way to think about it. It explains why time seems to only move forward. I mean, you see glasses fall and shatter all the time, right? But have you ever seen a pile of broken shards spontaneously leap off the floor and perfectly reassemble themselves into a glass? Of course not. We remember the past, which was more ordered, and we move toward a more disordered future. So the arrow of time is really just the arrow of increasing entropy.
So this physicist, Ludwig Boltzmann, he had this incredible aha moment. He realized that a disordered state isn't just some vague tendency, it's pure, cold, hard probability. There are just so many more ways for things to be messy and disordered than for them to be neat and ordered. A shattered glass is a high-entropy state because its pieces can be scattered in a gazillion random positions.
And this right here, this is our first major clue. Our universe, with its intricate galaxies, its perfectly balanced stars, its complex life, is a state of incredibly low entropy. It is highly ordered. And from a purely statistical point of view, that makes it a massive cosmic longshot. Our reality is a wild, improbable exception to the universe's favorite rule. Okay, so now let's zoom all the way out and see how this plays out on a truly cosmic scale. Because if the universe has to follow this law of disorder, then its ultimate fate is, well, pretty strange and empty. But it's in that emptiness that the statistically impossible can start to happen.
So, way out in the distant future, we're talking trillions and trillions of years from now, some models predict the universe will reach a state of heat death. It's reached maximum entropy. Just imagine a cold, dark, perfectly uniform void. But here's the thing, even in that perfect, boring disorder, the laws of quantum mechanics say that random fluctuations are just inevitable. Little particles will flicker into and out of existence for just a moment.
And if you have an infinite amount of time, I mean literally an eternity for these flickers to happen, then it's not just possible, it's statistically guaranteed that one of these random fluctuations will, by pure chance, assemble itself into something incredibly complex, something like, say, a fully formed, conscious thinking human brain. And that is our paradoxical suspect, the Boltzmann brain.
Now, the really brutal logic behind this paradox is all about statistical cost. Think about it. To get our universe, you need a ridiculously low entropy starting point, the Big Bang, and then 13.8 billion years of very specific, ordered evolution. The statistical price tag on that is enormous.
But to get just one tiny brain with a bunch of fake memories, well, that's a much smaller, much cheaper dip in all that entropy. Statistically, it's an absolute bargain. And nature, well, nature loves a bargain.
So if the universe runs long enough, it's going to produce a staggering number of these low-cost, spontaneous brains. And it will produce far, far fewer of the incredibly high-cost, orderly universes like the one we think we live in. Which brings us to the chilling conclusion. Observers who evolved the long, hard way, like us, should be vastly outnumbered. Statistically speaking, it's more probable that you are a fleeting Boltzmann brain than a person who actually evolved on a planet called Earth.
Yeah, I know. This conclusion is so absurd, so fundamentally unsettling, that physicists are working really hard to find a way out of it. I mean, if your scientific model ends up predicting that you can't even trust your own observations, that model has a major problem.
So what are the escape routes? Well, there are a few ideas floating around. Some scientists attack the very premise, saying maybe our models of an eternal, endlessly fluctuating universe are just wrong. Others try to redefine what an observer is, arguing that a real conscious mind needs a body and an environment to be real, not just a lonely brain. Some use what's called the anthropic principle, which basically says, of course we see a stable universe, because it's the only kind of universe where we could have evolved. And then there's the simplest, most direct escape of all. If your theory predicts your own brain is probably a fake, then your theory is almost certainly broken. But here's the catch. None of these solutions are a slam dunk. Every single one has its own issues, its own counterarguments, and physicists are still debating them fiercely. For now, the Boltzmann brain remains this troubling ghost in our cosmological machine. It's a paradox that we haven't managed to solve.
So, while the smartest people on the planet argue about it, what are we supposed to take away from this absolutely bizarre thought experiment? Well, it kind of acts like a cosmic mirror, forcing us to ask some really, really deep questions. First, it hits you right where you live. It challenges your most basic fundamental assumption that what you see, what you feel, and what you remember is real. If a totally logical physical argument can lead to the conclusion that it's probably not, then how can you ever be 100% certain of your own existence?
It also makes you ask, what even are you? Is your consciousness, that feeling of being you inside your head, is it just a very specific, very lucky arrangement of atoms that could be slapped together by pure chance? Or does being truly conscious require a history, an evolution, and a real connection to the world around you?
And you know, maybe the biggest lesson here is a warning about the limits of our own knowledge. This paradox shows us what can happen when we take our physical laws and push them to their absolute extremes, out to infinite time, to the very edge of the cosmos. It's a powerful reminder that our best theories might have boundaries that we just haven't discovered yet.
In the end, whether the paradox is true or not, it leaves you with this incredible sense of wonder. It suggests that our orderly, predictable, and seemingly normal existence isn't the default state of the universe, not even close. Instead, it might just be an extraordinary, improbable, and unbelievably precious exception to the cosmic rule of chaos.